Good afternoon, everyone. Welcome to today's workshop, Introduction to ChemDraw. This is part of our Data at Your Desk workshop series for the spring 2021 semester. My name is Dr. Nick Grush. I am the STEM Data and Research Librarian at FSU Libraries. I'm also one of the subject liaisons to the chemistry department here at Florida State University. And I also have a background in chemistry before I came to FSU, which is where I learned ChemDraw and used it quite extensively. So just a brief overview of what we will be talking about today. I'll give a brief introduction to ChemDraw. We'll go over the interface and the main toolbar. We'll sort of look at what each of those is, some of the functions and features of those. We'll go over some data analysis tools within ChemDraw after you draw your chemical structures. And then we will go over at the end, just briefly, the interface between ChemDraw and scifinder. And I'll mention if you have any questions for today during the presentation, please feel free to drop those in the chat. Josh will be monitoring the chat and will let me know if there's questions or answer them himself if able. And so before I get started, I just wanted to ask, feel free to put this in the chat. Have you used any sort of chemical structure drawing program before, whether that was ChemDraw or whether that was some other sort of structure drawing program, either web-based or desktop-based? So if you could briefly drop that in the chat, that would be super awesome. Okay, awesome. ChemDraw and Spartan, nice. All right, so today's workshop will just be, is going to be sort of an overview of some of the basic features of ChemDraw, but we will go into some more data analysis type things as well, and some predictions that NMR ChemDraw can do. So hopefully you'll come away with this, having some new knowledge and new insights into all that ChemDraw can do. All right, so what is ChemDraw? So just a brief introduction. ChemDraw is a scientifically intelligent application for chemical structure drawing and analysis. So the main feature, obviously, of ChemDraw is that you can draw chemical and some biochemical structures and reactions, including organic molecules, organometallic complexes, and there's even some features now for proteins and other biochemical structures as well. Within ChemDraw, you are able to calculate molecular weights and chemical properties. You can prepare publication quality graphics, which is a really, really great feature. And it's one of the big reasons a lot of folks use ChemDraw is to get those sort of reaction schema that they can draw and then put into a publication. And then you can also convert between chemical names and structures if you're looking for one or the other, if you potentially draw a new chemical or you find something through a search and you are looking for it to predict the structure. So just a brief history. So prior to the invention of ChemDraw, a lot of chemical graphics drawing was done by hand. So it was a lot of times done by on-campus graphic arts folks. Really, the origins for ChemDraw came in 1984 when Apple introduced the Mac. And with this initial Mac, it came with the MacDraw program. And then based on that program, a Stuart Rubenstein, which is a PhD student, developed a program based on this MacDraw for creating chemical structures. And this really took off. A lot of folks were really interested in this. And so ChemDraw was sort of born. And over the years, there's been many iterations of ChemDraw to what we have today. And ChemDraw is now overseen by Cambridge Soft, which is part of PerkinElmer. So if you're interested in using ChemDraw at FSU and you don't already have it, you may or may not have it already on your computers. We have it available in multiple places. So it's available in the libraries. So if you're in Strozier, Dirac, or the engineering library on campus, it is available using the scientific desktop. There's also a campus-wide license through the chemistry department. So if you go to the chemistry department's website and look for downloading ChemDraw, information for that, anybody with FSU credentials can download a copy of ChemDraw to their personal computer. And then if you don't have access to any of those, but you just want to try out ChemDraw, there are 30-day free trials that are So ChemDraw itself is actually part of a larger suite of programs called ChemOffice. So when you download ChemDraw, you do it, say, through the chemistry department or through the Cambridge Soft site, it'll often download as ChemOffice, of which ChemDraw is a part. There's some other programs in here that can also be useful depending on what applications you're wanting them to use them for. We won't necessarily have time to go over these in detail today, just due to time, but we'll talk just briefly about them. So the first is Chem3D. This lets you build, visualize, and analyze 3D models of chemical structures. ChemScript is a chemical programming environment that actually provides access to sort of the underlying chemical intelligence, the underlying scripting that goes into ChemDraw. If you're looking to automate different operations, this actually takes advantage of a Python package that's associated with ChemOffice. So it'll download that to your computer as well. And then ChemFinder is a database manager and search engine that searches documents, spreadsheets, databases for matching chemical structures. All right, so in today's workshop, I'm going to demonstrate some of the features of ChemDraw. And to do that, we're going to use some example structures. And I'm showing on the screen the example structures we're going to use. We're going to start with just the basic benzonitrile and then sort of work our way up. And we'll use each of these to show some of the different features and some of the different data analysis tools that we're going to look at. All right. And at this point, I'm going to exit out of the slides for a bit. And then I am going to get into ChemDraw. All right, can everybody see ChemDraw on my screen? Awesome. Thanks, Jill. All right, so this is the sort of home page or landing page that you will come to when you first open ChemDraw. I have the latest version of ChemDraw on my computer, so this is ChemDraw 20, and this is available to download, I believe, on the computers at the libraries. If you're in the physical library spaces, we have ChemDraw 17. They come out with a new edition pretty much every year. There's not a whole lot of differences, just some buttons kind of moved around here or there, but most of the features in between those are pretty much the same. So you'll notice here when you first log in or first upload your ChemDraw, you'll often see this tools bar over here. So this is what I like to call the sort of main toolbar, or like, starting toolbar. It has a lot of your really essential features for drawing chemical structures. So I always like to start here and sort of go over some of these different features. We'll look a little bit later to some of the menus and some of the different options that you have within those menus. So if we go into this main toolbar, the first thing we'll notice are the bonds. So you have options for drawing your chemical bonds. So the first button is a single bond, and you just select this single bond option, and then you'll see we have this little cursor icon when you're hovering over your drawing space. If we just click once anywhere within this space, you'll see we now have a chemical bond. And this is displaying between two carbon atoms and then the hydrogen. So it's sort of giving us an organic structure of drawing. If you want to draw another bond, you just hover over this little blue circle. You'll see when you're at the end of the bond, there's this little blue circle that comes up, and you just click again, and you can draw another bond. And I am going to actually make this a little bit bigger so that it's easier to see on the screen. All right, that shifts it to landscape mode, but that is okay. All right, so that's our single bond. If we want our multiple bonds, that is the button right below. You'll see here, all we see when we just click on it is a double bond. So we have two bonds. Adding a bond is the same. Just hover over one of the end of the bonds here, draw that double bond. If you want to do anything other than a double bond, you click on this little arrow here at the bottom right corner. And when you hold that, you'll see different options for different chemical bonds. So you have like a triple bond, there's even a quadruple bond, and you'll see, sort of this dashed, like solid type of bond that you might draw if you have like some sort of a resonance structure or that sort of thing. So I'm just going to click on triple and then do that somewhere off in space, and you'll see we have a triple bond. And what this will do is once you select this, it'll keep this, whatever you just previously selected, as whatever bond is the default in this multiple bond window until you unselect that. So if you want to go back to double bond, you have to select that again. One alternative way to get multiple bonds is to draw one of your single bonds and then just hover over it here in the middle. You'll see a little blue box sort of appears over that. If you click that again, you can add another bond, and you can keep doing this to get more bonds. This is just kind of moving it. Okay. So different ways to do that. So those are our basic single and double bonds. If we want to add dashed bonds or wedged bonds, that's what I want to cover next. So if you're looking to sort of display what your molecule looks like in three-dimensional space, Whether your atom is going behind you or whether it's coming out in front of you, you're going to use these dashed and wedged bonds. So if we look at, or hashed, I guess, I always call it dashed. If we look at a hashed bond, this is something going behind us. Just click the hashed bond. We can draw that in the same way. If we want to draw a wedged bond or a bolded bond, we just click those. And same way. So that helps us represent our molecule in three-dimensional space. And so right now, so far, we've just kind of drawn several different bonds. You've had organic chemistry, you know that these are carbon-carbon bonds, right? You know, you've got hydrogens coming off of them. So what if we want to, say, add a different atom, right? If we want to add, say, a nitrogen or an oxygen, well, we can use this atom substitution tool or text tool. So we just click on that and hover over, say, one of the end of your bonds or, you know, one of the places where your bonds meet. And click that. And then there's a couple different ways you can do this. You can just add in text-wise, just type in the text for whatever element that you want. So say we want an oxygen, we can just add that. Another way you can do it is if we go to View, and this has a lot of our different toolbars and windows that we'll get into in just a little bit. If you go to Show Periodic Table window, you'll see you get a nice little periodic table that comes up. And this has all, or at least most of, your different elements. So you can find your oxygen here. If you want, say, an aluminum, I have to make sure to that. If you want to do an organometallic complex where you're adding a transition metal, you can say add a palladium or something like that. So this is another option if you're looking to add different elements. You still need to be in this atom substitution tool and have the best ways to have some sort of text box already open when you're doing this. All right, I'm gonna X out of that. All right, so a couple more things before we go in and actually draw a structure. So the eraser tool. So we're all drawing, right? You know, if you're drawing, just kind of like when you're typing in Word or something, you know, you might make a little error, a mistake, something, a typo, something like that. There's a couple different ways to rid of those. There is an undo button in ChemDraw. So up at the top, just like you would see in like your word processing program or Microsoft Office program. But if you say want to go back either to what you just did previously, or if you want to go back to something you did earlier in your structure, say you want to revise it, you want to add in new bonds or new elements, you can use this eraser tool. So if you do that, hover over your bond and you can erase. If you want to get rid of a whole structure, instead of having to erase every single bond and every single element, you can either use the lasso tool or the marquee tool. I like using the lasso tool because it lets me select what I want to erase in case I only want to do part of the structure. And then you can just hit the backspace key on your keyboard. All right, and then the final thing that we'll talk about is down here at the bottom. You'll see these different chemical rings, right? These sort of predefined chemical rings. So often when you're drawing structures, they're going to have some sort of a ring to it at some point, or multiple rings within the structure. You can draw these out by hand if you like. But if you're drawing, say, a lot of, you know, benzene rings, right? The 6-membered rings with alternating double bonds. Drawing a lot of these in your structures is going to consume a lot of time, right? So what ChemDraw does, it's really nice, is it gives you these uh, sort of six preloaded chemical rings. They go all the way up to this cyclooctane, and you can go as small as a cyclopropane. So these are really nice if you're using these to base your chemical structures on. All right, so that's that. I just want to stop and see if there's any questions anything I've talked about so far. If not, if you could give me either a thumbs up using the reactions or just say in the chat that you're good, that would be awesome as well. All right, awesome. All right, so now we're going to draw this benzonitrile. So we can do this using what we've talked about so far. So we can kind of stick to our main toolbar. And then I'm going to walk through each of these as we're doing this in ChemDraw. But this is on the slides, which you'll get shared out after the presentation, just in case you want to refer back to this later or do this on your own. So if I go back to my ChemDraw, and then the first thing I would do here is draw or click on your benzene. So the 6-membered ring, click on that, get that into ChemDraw. Then we can add our bonds. So here, there's only one group off of our benzene, and we're not specifying, 2 different groups or whatever, so it doesn't really matter. I'm going to put it here in this upper right corner. So if we hover over on this bond here, you see our blue circle. We do 1 click, that gives us a single bond. Then we want our multiple bonds. So we need to select a triple bond. So if we scroll over to triple bond, that's now what is selected. Hover our cursor over the end of this bond. We have a triple bond, and that's connected. And then the final thing we need on the end is our nitrogen. So we can hover over that. You can see when you do hover over it, it sort of changes a little bit to this A kind of like text feature. It's kind of hard to see, but you get a little text box. You can type in, and there we have it. That is our benzonitrile using all of the different tools we just talked about. All right. All right. So now that we've talked a little bit about the main toolbar, the next thing I want to talk about are some data analysis tools. So ChemDraw can be used to really do some nice preliminary analysis of your chemical structures. Can be used to predict different properties of your compounds. So it's really useful if you are in the lab and you make something new. Maybe you want to predict some of the chemical properties, compare those to your experimental properties. ChemDraw is really nice for that. So we're going to talk about 3 different types of data analysis tools today. we're going to go over the structure analysis window and what you can find there. We're going to go over the chemical properties window, and then we're going to go over how you can use ChemDraw to predict proton and carbon NMR shifts. We'll talk a little bit more what that means when we get to that point. Some other things you can do within ChemDraw, which we won't have time to get to today, is you can also analyze the stereochemistry of your compounds where it is in three-dimensional space. You can also predict some other atom or bond properties as well. So I'm going to stay in this window. So we're going to be going back to ChemDraw here shortly. So the first window we're going to look at is the structure analysis window. And so you can see on the screen, this is a screenshot of what the structure analysis window will look like. And it will show these different properties of your compound. So it will show the molecular formula of whatever you've drawn. It'll show the exact mass and the molecular weight based off of the periodic table weights. If you are looking at a mass spectrum of your compound, you're looking at how the compound breaks down when you shoot it through a mass spectrum. It'll show you sort of some predicted peaks for your MZ +1, +2. And then it'll also give you a predicted elemental analysis for the amount of nitrogen, carbon, oxygen that's in your compound, which is useful when you're doing elemental analysis of a new compound. So to show you what that looks like, if we look in ChemDraw and we go back to this view menu, so we'll be looking at this quite a bit because this is where you'll find all of your different toolbars and windows that you can look at. You can see there's a lot of different choices. And there's actually even more than they show here. If you go to other toolbars, there's all kinds of different toolbars that you can use. But a lot of these can also be found in some of the different menus as well. This is just another way that you can use them. So if we go to this analysis window and we click show analysis window. So you'll see what this does is it brings up our little analysis window with formula, exact mass, weight, MZ elemental analysis. And right now it's looking at our benzonitrile molecule that we've drawn previously. And you can even change the decimal points if you want to get more exact or you're trying to get a more exact weight per se. You can go up to 5, it looks like. So you can go all the way up to 5, or you can have 0. But usually it will default to 2. And you can take any of this and you can paste it into ChemDraw just by clicking this paste button. Paste it all the way at the top. And so if you're, say, saving this, what you do in ChemDraw for like a report or a presentation, and you want some of this information, you can paste this into ChemDraw and then save it in a different format. And you can actually, if you uncheck some of these boxes, say you don't want, like the MZ elemental analysis, and you just want the first 3, you can paste those, and then you just get those first 3. All right. Those. All right. And then just to note, all of this, I said this earlier, but all of this data is predicted data. So this is predicted based off of previous data, and then it's pulling from ChemDraw's database to analyze this for experimental purposes or you were going to publish this, do a presentation on it, you would need to compare this to experimental data to get a good analysis. So the next window we're going to look at is our chemical properties window. So if we go back to view, and then it's right below analysis, so it's really, really awesome. So if we click chemical properties window, shows up here on the side, and you can see we now have predicted chemical properties for our compound. And you can see it sort of runs the gamut. There's a lot of different ones here, maybe more than you need to know for your specific analysis, but it really covers a good amount here. So like boiling point, melting point, you know, pKa's if that's available. And this is all dependent on, one, if ChemDraw can predict this based on information for similar compounds, or if that compound is already available. This compound, bentonitrile, is a very commonly known compound. It's been used extensively already, so this is why you see a lot of different properties for this already. Some of your newer compounds may not have all of that information, but you'll still be able to predict some of these properties here. And you can, again, paste as much of this information as you want into ChemDraw. But the nice thing here is you can actually generate a report. So if you click report, you can get this pop-out window that's just like a notepad text file. It has all of this different information. It has physical property reports, and it has references for where the information was pulled from, maybe what methods were used to get those values. So this can be really nice as well if you're doing some sort of methodology and you need to put these properties in, you need to cite those. And then you can save this to your computer in wherever you save your file. All right. All right, so those are those two windows. All right, any questions at this point? Are we still pretty good? Thumbs up or questions in the chat if you are. Sweet. Awesome. All right, so we've gone through those two windows. So now we're going to look at another example structure, caffeine. Very, very applicable if you love coffee or you love tea, especially caffeinated tea. I always like using this as an example. It's always very, very applicable. So we're going to now draw this, and we're going to do a chemical properties and structure analysis using these two windows that we've shown previously. And so I give a couple of hints to draw this structure. If you're drawing this structure on your own, you don't have to do it necessarily in this particular order. This is just sort of how I like to do it, to sort of try and do it as quickly as possible, which can be important if you're drawing a bunch of structures at the same time or in the same session. I always like to start with the preloaded rings. Here you can see those are attached to each other. You have your 6-membered ring and then 5-membered rings. I like to attach those first, and then attach your bonds, and then do your atom substitutions for your different atoms. So I'm going to pause this. Go back to move some of these around just so it's a little bit easier to see. I'm going to circle these with my lasso, backspace, so we have a clean window. All right, and now we're going to draw our caffeine. All right, so we want to select our 6-membered ring first, so our cyclohexane. And then we want to select our cyclopentadiene, so our 5-membered ring. I'm going to click up here, sort of at the top right. You'll see it sort of attaches this ring, but it doesn't attach it with the 2 rings connected in 2 spots. So you sort of have to rotate this until it's connected. You'll see the little blue circle comes up on both spots. So we connect this. And now I'm going to put in our single and double bonds. So we have a single bond here, 2 positions away from our intersection, and then another single bond here, single bond here. I'm sort of cheating. I have something to reference to, just magically appearing. So now we have our bonds, and I always like, just a personal preference, do our atom substitutions. There. So we have our nitrogens, where our single bonds meet our rings. And then at the top of our double bonds, draw in our oxygen. All right, so we've added all of those in. One thing I will touch on now is when you see structures a lot of times in the literature or in a textbook, you'll often see these different elements labeled with a particular color, right? Like nitrogen might be blue, your oxygen might be red, it might be in a different font, it might be emphasized. A lot of that is, very artificial. It's just sort of meant to show differences between the two. But it is nice visually for your readers or others that are looking at your structures, at your work to see and to follow. So how we do that is a couple different ways. So if we say click our oxygen here, if we go up to the text menu and we look at fonts, you can see we have quite a few different choices for font, right? Not necessarily as many as like Microsoft Word, but you probably won't use as many of those. So I like Arial or Times New Roman. I usually keep mine in Arial. You also have style. So if you want to bold something, if you're typing out, say, a formula and you want to superscript something or subscript something, you can click these here or click the F9, F10 commands. And then you can also change the size. So you can see you have a few different pre-selected options, up to 24. Or you can click other if you want to do a custom option. So I am going to bold this. So I'm going to bold our oxygen. As you can see now, if I click out of that, and now I'm going to add a color. So you go to the colors menu. So there's a few different pre-selected colors for you to choose from. There's some ring fill colors. If you click this other, you get some more choices, right? You get some of your basic colors, red, yellow, orange, green, etc. So you get more choices than you have on that menu. If you want to define, say, a custom color, if you want something that's kind of a shade in between, you can define custom colors, and it gives you your nice sort of color window where you can pick what hues that you want, different saturations. You can actually type in your red, green, blue. If you want to really get specific. I don't normally do that necessarily, but if you have a particular sort of shading that you really like, that is an option. And you can save those under your different custom colors. But I'm going to cancel that and just use the red that they have here in sort of our pre-selected menu. So I'm going to do that for the other oxygen. And then for the nitrogen, I'm going to do this blue. And then the other options, if you go over here to the side, you'll see you can select your colors from this little sort of black box looking thing initially. So now it looks blue because I've selected blue. Go here. And then if you want to bold it, you can select bold from here, from this toolbar. So a few different options there. And there we go. And I actually forgot to add a nitrogen here. There's one more nitrogen. Just noticed that. So let's do that. Bold it and make it blue. All right, and now we have our caffeine. So now it looks nice and pretty, a little bit of color to it. So it sort of pops out a little bit if you're looking at it. If we look at our analysis window and our chemical properties window, we'll see it's given us our chemical formula, our mass, our elemental analysis with our carbon, hydrogen, nitrogen, and oxygen. If we want to paste all of this into ChemDraw, we can just click paste. Let's undo that. It's pasting it over there because I have a text box open with the text tool. Let's undo that and click paste so we get it here down below. Sort of move this out of the way and to the side. And then we can paste any of these here as well, or we can report. And so while we're on this, one more thing you can do. So we know this is caffeine already because we mentioned that before. But say you're getting a new structure and you're looking to predict the name of it, right? Or maybe you know it's a known structure, you're trying to get the official organic chemical name of it, right? Which some of those can be kind of long, have some names we don't normally use. So if we go up to our, pause this real quick. All right, we'll resume sharing. And if we go to our view, let's see. So if we go to our structure and you go all the way down here to the bottom, you'll see you have this convert name to structure or structure to name. So if we say highlight all of this structure and we go back to our structure, we say convert structure to name, or you can use the Alt-Control-N commands. You can see this now gives us the official chemical name of caffeine, right? So this can be really useful. You can also, especially for a known one, you can look it up. You can do a structure search for this and find it. You're just doing this in ChemDraw, you want it nice and quick. It is right there. If you also have a name, for a structure that's known to ChemDraw, you can also type that in and convert the name to the structure. All right, awesome. All right, is everyone still good? Are there any questions on what I just did? Awesome. All right. All right, so the next thing we're going to talk about, and we'll stay here in ChemDraw, is predicting NMR shifts. One of the most powerful features of ChemDraw, or one of its most powerful predictive features, is its ability to predict both proton and carbon NMR shifts of drawn chemical structures. Before I go into that, does everybody here know what I mean when I say NMR? Awesome. All right, so I won't go too much into what NMR is. We just have that in case you haven't come across that yet. But what ChemDraw gives you the ability to do is if you have a chemical structure, is it allows you to predict both the proton and carbon NMR spectra. So if we have our caffeine molecule, we'll stick with this molecule that we have on the screen. We have this selected. If we go up to our structure menu, so we're back to our structure menu. We go down to the bottom, you'll see we have two different options. So we have both predict proton NMR shifts, and we have predict carbon NMR shifts. So the first that we're going to look at is proton. So we have our structure selected. And all we have to do is click predict proton NMR shifts. And what this will do is this will open a new page within ChemDraw. We're still in our ChemDraw session, but it opens a new page or document within ChemDraw that gives us our proton NMR estimation. And you can see we have the structure at the top. It gives us our predicted shifts up here. So it gives you the predicted proton shift. And then if you hover over that, you can see it sort of highlights this down in the spectrum. If you look down there, it's sort of in very light green, sort of hard to tell. I'm not sure why they picked that as the color. But you can see if you hover over this, it points to that particular chemical shift. It tells you down here at the bottom. So it sort of tells you different information for this. It gives you what solvent this is predicting it in. So typically, your proton NMR predictions in ChemDraw are going to be done in either DMSO, so dimethyl or it's going to be done in chloroform. I believe it defaults to DMSO, but you can go into the options and change that to chloroform. And then it gives you the shifts and sort of the base shift and sort of maybe why it's predicting that it's going to be slightly off based on different functional groups and that sort of thing. And then it'll give you coupling constant predictions as well. And then the last thing it'll do is it'll give you sort of an estimation quality, and it rates it as good, medium, and rough. Caffeine is a very well-known, well-researched structure. It's already likely in ChemDraw's database. The structure's been published numerous times. So it's pretty confident in what the chemical shifts are here. So everything is good. If you had a new structure that you were looking at, or you were making alterations, you were changing out different bonds and elements through experimentation, you might get some medium or rough predictions as well. So sometimes you will see this in those cases. But this gives you a really nice sort of first indication of, what should my NMR spectrum look like? If you want to just do this right within ChemDraw. And you can nicely save this, if you file, save, and then you can sort of print this out, either keep it in a notebook or keep it with you when you're experimentally looking at your NMR. If we go back to our caffeine molecule, we can do the same thing for carbon NMR. So if we want to predict the carbon NMR shifts, we can just click predict carbon NMR, and it gives us a very similar looking document. Now we see our carbon NMR has our different shifts labeled, the different experimental conditions and protocol. And then its estimation quality. So this is a really, really nice tool within ChemDraw. Something that if you are doing analysis, especially on an organic compound, one of the first things you're going to do is get an NMR of it, right? Get a proton NMR, maybe get a carbon NMR. So this is really nice if you're working with those chemical structures, you're doing experiments, and you want to see what the estimated NMR shifts are. While you're in ChemDraw, some of them are available on online databases. This is just a really nice way to sort of keep everything right within ChemDraw. All right. All right. So sort of the next thing that we're going to look at, and sort of one of the final things that I'm going to show today is how to take a structure that you've drawn in ChemDraw and do a structure search on that in an online database. The specific one we're going to look at is scifinder. And I'll ask this as well. Is everyone familiar with scifinder? Have you used scifinder before, or some similar type of database? Okay, awesome. So we'll talk about that very briefly. We can do a whole presentation just on scifinder and all its awesome features. But scifinder is a online database. We have it available through FSU libraries. And this allows you to do structure searching of chemical compounds. So if you think of like a database that you might use in one of your other classes where you're doing keyword searching, you're looking for articles on a particular topic. scifinder, it's probably its most powerful features. You can do a structure search to find different articles on a particular structure. You can draw reactions to get articles on a particular reaction or different chemical properties. So you can use scifinder right from the scifinder interface. You'll see that when we go into it. But one of the nice features that ChemDraw now has, especially some of the more recent iterations of ChemDraw, is the ability to sort of interface between the two. So if you go up to this search menu right here, so we go up here, you'll see we have two different databases. So scifinder is what we're going to look at. You can also search a database called Reaxes, which is made by a different company. It's a very similar database. But typically in chemistry, I would say scifinder is probably the one you're going to see the most. So if we say search scifinder, while we're still in ChemDraw, you get this little pop-up menu, and you can do what's either called a substance search or reaction search. And you can do this in scifinder itself as well. So here we can do either a substructure or an exact structure. An exact structure search is going to look exactly for this structure. It's going to look exactly for our caffeine molecule, maybe some sort of isomers of that as well, but it's going to look for this particular structure. A substructure search is going to look for all compounds that have this molecule as a part of it, that have this particular structure, but it may have other groups as well, right? It may have other additional functional groups in there as well. So this is sort of our most narrow search. So if you think of a regular database, your exact structure search is your most narrow search. Your substructure search is getting a bit broader than that, right? Sort of looking for things that are similar, but maybe not exactly the structure. You can also do a reaction search, which by default is a substructure search. So if you're looking for reactions where, say, you get this as a product, right? Where they are making this compound as a product, or if they're using this compound as a reactant, you can also do that type of a search. So I'm going to do an exact structure search. So if I click this option and click OK, all right, so let me make sure. All right, so if I go over here. All right, can everybody see the scifinder login window? Okay, awesome. I know sometimes Zoom doesn't switch things over right, so just wanted to make sure of that. So here's login page. I have a dark reader on, so I'll make that light. You'll see it already recognizes me. And you can create an account for scifinder if you don't have one. Just going through our library's database using your FSU credentials. So anybody can have an account through FSU to scifinder. So I have logged in here, have my password. So if I log in, since we're already doing a search, it's already pulling our structure. It's already going to go right to our results page. And you can see this is what our results page looks like in scifinder. So the first thing it's going to have is the structure that we're looking for. And then here you'll see a bunch of other structures that might have results that have this as part of a mixture or something else attached to it. But if we look at this, let's click on the first one. We can see sort of a record page. So, if you think of a database, you click on an article, you get sort of a record page. This is your initial record page in scifinder. You can see it has some of those chemical properties as well here. But you can also get references. So if there's references associated with this structure, you can click this Get References, and then you can actually select how you want to limit those. If you don't limit them, you're going to get a whole gamut of results, right? Just like any other database. So if you say you want to know, preparation, right? If you want to know the preparation of this particular compound, you can check that box and you click Get. And now you see a search results page, right? With a bunch of different articles on it. So this is very, very sort of quick intro to scifinder, but sort of the nice point here is that there's a really nice interface between ChemDraw if you're drawing structures there, and if you want to do searches for them in scifinder. You can also, if you just go to, if I just click scifinder up here, if you just log into scifinder from FSU, from the library database, you'll get this homepage, and you can also do structure searching in here. There's its own structure editor. It's not as robust as ChemDraw, but it works fairly well through this website. All right. I'll go back to this. All right. Okay. So are there any questions on any of that? Doing NMR predictions in ChemDraw or using ChemDraw and scifinder together? All right, if there are none, we will do one more example where I will just do all of these different things at once. So if we have our alpha D glucose here, and we want to do a structural and chemical properties analysis, predict the NMR spectra, and we want to search for that in scifinder. We can do that using everything that we talked about today. So going to our ChemDraw. All right, so if we share our ChemDraw. All right, so I'm going to open a new document. So we have a nice fresh page. Let's say we want to draw our alpha D glucose. Here we're going to use one of our chair cyclohexanes, right? So if you've done organic chemistry, you know that a cyclohexane, draw that often in a chair conformation, right? So we're going to use that. I'm going to make this bigger again. It made it smaller. All right, and now we're going to add in our different bonds on each of our carbons. Oops, I do not want it going down. I want it going up. Going in this direction, then going straight down. And then here we're going to have some OH groups or some hydroxy groups. So we'll have those on the ends of our single bonds. And then use our atom substitution tool here, just one oxygen. And so this is our molecule. You can see our structure analysis and our chemical properties analysis have populated. So we can paste this information. Again, I had the text bar still open. So we'll click out of that, click on the lasso, paste this in so that it's easier to see. And then let's say I just want these first 4 from our chemical properties, and I want to paste these into ChemDraw. If I just select the first 4 and hit paste, it pastes that right below the previous text. And we can also generate a report as well if we want all of this other information. So that gives us our structural and chemical analysis. If we want to predict the NMR, I need to first highlight this. So we highlight our structure, go down on our structure menu, hit predict NMR shifts. We're just going to do proton. You can see this one, we have a lot more hydroxy groups. The way things are arranged, a little bit messier than NMR, but our glucose is also pretty well studied, extensively studied by researchers. So this is also something in ChemDraw's database. And then you'll see if you go down, protocol of our NMR, it talks about all of the different corrections that it made for the different functional groups and the different positions that those are in. So this gives you a really, really nice report here. Computer's moving a little slow, so it's taking time to actually scroll. So that's our NMR. And then the last thing that we'll do is we can do a search for this in scifinder. And let's say we do a substructure search this time. We tried our exact search last time. We'll try a substructure search this time. If we hit OK, all right, so if I use share this, okay, scifinder is open in another window. Yes, it is. So I'll close that and then hit OK. And so this one will take slightly longer because we're doing a substructure search, so this is even broader. But now you can see our search results page, which looks very similar to what we had before. And of course, if you've looked at glucose before, you know that there's a lot of different conformations for it. So scifinder is going to have results based on each one of those. And they'll sort of draw them in this conformation, just regular cyclohexane, but it'll have sort of the 3 dimensions represented by dashes or wedges, which you can also do within ChemDraw as well. All right, so that is all that I had today. So I hope that gave you sort of a nice overview of the features of ChemDraw, was a nice introduction to some powerful predictive tools, showed you the interface between ChemDraw and scifinder, so that you can do chemical structure searches based on something that you're drawing in ChemDraw, which is a really nice feature that they've introduced in the last few years as the products are more and more becoming connected. If after today, if you have questions about anything that I talked about today, or anything on ChemDraw itself. There are some resources available from Cambridge Soft or Perkin Elmer, which are the folks that manage ChemDraw, that manage the software itself. There's sort of some overview videos, some intros to get started. If you're ever working with ChemDraw and you have a specific question about the software itself, or you're trying to do something and you keep getting like some sort of error message or something isn't working out right, there's this really nice support contact that you can get to on the Perkin Elmer page. These folks are great. They're usually pretty responsive. I know I've used it before. If I'm having issues or if ChemDraw is being really finicky for some reason, or if it's not working on your computer for whatever reason, these folks are really helpful. And then we'll be sending out the slides later on after the workshop today. And then finally, I am always available if you have questions that you'd like to do a more sit down one-on-one consultation on ChemDraw, whether you're using it for your research, for a class. I am more than happy to sit down and work with you on it. And my contact information is on the screen. All right. Thank you very much for your attention today, for coming.